All right, guys. So as I was saying before, we got interrupted. So when we are multiplying expression containing or consisting of the same symbols, indices are used, right? You remember we talk about power, the power meaning that it tells the amount of times when the number occurs when you're multiplying the base, the same base. Well, we are referring to the same thing here. When you're dealing with the same symbol, meaning you have the same base, you apply the rules that you learn from indices. For example, if you have m times m, you apply the same rule for indices. So you raise m to the second power. And anybody can tell me why we raise it to the second power? Miss Cox, why do we raise m to the second power?
Sir, because it is multiplied 2 times.
Not because it's not multiplied 2 times, it multiplies 1 time here because it's only one multiply symbol you have here. So it only multiply 1 time, right? You agree?
Yes, sir.
Right. But what happens when you multiply the symbol by itself? The symbol occurs 2 times. So the power tells you how many times the symbol occurs or the base occurs. So the reason why we raise it to the power 2, because when we're multiplying m by itself, in this situation, the m occurs 2 times, so we raise it to the power 2. All right, everybody's clear with that. All right, moving along. When dividing between numerator and denominator, we cancel where possible. All right, so we are just going to recap the same rules that we were looking at just now with directed numbers for positive and negatives. We're going to recap the same rules for multiplication. All right. Now we are now reviewing the rules based on the algebraic quantity. So if we are multiplying a positive x, sorry guys, if we are multiplying a positive x with a positive y, then remember, when we're multiplying in algebra, we simply just group the letters together and bearing in mind that there's an invisible multiplication sign between them. So we multiply x times y, we get xy. But remember, we're multiplying positive times positive. So it's going to be positive xy. Now, when we have positive values in our answer, we don't have to write the answer with the plus sign in front of it. It is understood that when you write an answer without a plus sign or without a minus sign, we take the answer to be positive, all right? So positive x times positive y give you positive xy, which is written as just xy. All right, here now, if we follow the same principle that we have up here, if we're multiplying 5x times 3y, now we treat the numbers separate from the symbols. So we multiply the numbers together. So we have 5 times 3. And then separately we multiply the letters together. So here we have x times y. Now 5 times 3 give us 15. And x times y just give you xy. So the answer here would be 15xy. Moving along. Here now we have x times negative y. That would give you what? Well, we multiply the letters by letters, we get xy. But remember now, this is positive and this is negative. So if we're multiplying a positive times a negative, then the entire result going to be negative. So here we write negative xy for the result. Now, following the same principle as above, we'll multiply the numbers together. So if you want to multiply 2 times negative 3, or you want to just keep the negative by itself, so we multiply the 2x by the 3y, and because we have positive 2x with times negative 3y, when we multiply positive times negative, we get negative. Now we multiply the numbers together, so we get 6, 3, 2, 6. We multiply the letters together, we simply just put them together. All right, so the answer becomes negative 6xy. Here, we multiply the numbers, so we can say negative 4 times 2, we get negative 8. And then we have x times y. You just group the xy together, so we get negative 8xy. Likewise, down here, we multiply the numbers together. Negative 3 times negative 2 give you a positive, because once you multiply negative times negative, you get positive. Multiply the numbers together. 3, 2, 6. Multiply the letters together. We simply just group them together. We get xy. Right? Now, I would have explained to you why we write our result without the multiplication sign between them. Because for the ease of writing your answer, or to make it simple, we don't rewrite our answers with the multiplication sign between them. But when we see groups of letters together, it is understood that there are invisible multiplication signs between them. So you must bear that in mind. All right, any question about these examples that we have just gone through? Let me see your hands if you're okay with what we have just gone through. All right, let me see the hands of those who are those who still need some form of clarification of what happened just now. Is there any question here that you need clarification? So go ahead, Michelle.
Sir, I didn't get you get number 6 answer.
So this one.
Yes, sir.
All right. So remember now, if we're multiplying this quantity by this quantity, what you have to pay attention to is the signs. This one has a negative. That means the entire quantity here is negative. This one also has a negative. The entire quantity would be negative. But if we are obeying the rules of multiplying a negative times a negative, we know that when you multiply a negative by a negative, you get a positive, right?
Yes,
So far. So just by having negative times negative, that it automatically makes answer positive, right?
okay.
The 3x times the 2y. When we multiply these out, we multiply the numbers together. So in other words, 3 times 2, we would get what?
6.
And then we have x times y, we get what?
Xy.
All right. Now this plus sign that we have here, need not put it here. Once you write your answer without any sign whatsoever, it is regarded as being positive.
Okay, sir. Thank you.
All right. You're welcome. Any other question? Everybody clear on what we have done? All right, moving along. For division, remember the rules for positive and negative when you're dividing would be the same rules for positive and negative when you're multiplying. So if you're dividing a positive by a positive, so this is positive x divided by positive y, the overall fraction become a positive x over y. And to give you the answer without the positive sign in front of it, it's just simply x over y. Right? Because once you have any term written without any sign before it, it is regarded as positive. So that's the first one. The second one here, in the numerator of this fraction, we have negative what? Negative 3x. In the denominator, there's no obvious sign in front of it, but we know that this is regarded as positive. So if you're dividing a negative by a positive, the overall fraction becomes negative. So we'll have now, in the numerator, we have 3x. In the denominator, we have 2y. So this would be your answer. Is that clear, guys? Any question? Moving along. Here now, we're dividing. In the numerator, we have a negative 5x. In the denominator, we have a negative 6y. So the fact that you're dividing a negative by a negative, the overall fraction becomes positive. So we have positive 5x over 6y. Now we can leave the answer without the positive sign because it is understood that it is still be positive without the positive sign. All right, here now we have positive 4 in the numerator divided by negative 3 in the denominator. So we have 4x, positive 4x divided by negative 3y. So if you divide a positive by a negative, the overall fraction becomes negative. And so you have negative 4x over 3y. Any question? All right, so let me see the hands of those who are comfortable with the division aspect of what we have just gone through. Let me see the hands of anybody who needs some clarification. Is everybody clear on the division? All right, going once, going twice. All right, Mr. Shamar, you were saying something just now?
No, I was just saying I understand it complete to what Mr. so far.
All right, that's good. Moving along. Now, we had mentioned before that when multiplying expression containing the same symbol or consisting of the same symbol, we generally will use the indices property. So when the bases are the same, we count how many times or how many times the base occurs, and that gives you the power. Now, power is the same as index, and plural for index is indices. So if we are multiplying m times m, then we count how many m's we have and we raise m to that amount, right? So this is m to the second power. If we are now multiplying 3m times 5m, then what is obvious here is that we can multiply the numbers together and we can multiply the m's together. So if you multiply the numbers together, you get 3, 5, 15. If you multiply the m's together, because it's 2 m's that occurs, then you can raise it to the power 2. All right, so this becomes 3, 5, 15, m times m give you m squared. So that gives you your answer. Now, here we have negative m times m squared, which is a positive m. Now, the same rule occurs for power. If the bases are the same, you add their powers. So this base is m, this base is m. The power for this one is square. What is the power for this m here? What is the power for the first m in this question?
1.
The power would be 1. So when you have a base with no obvious power, the power is 1. All right? So if you have m to the power 1 times m to the power 2, to get your final answer in terms of the power, you simply add both powers. So 1 plus 2 give you 3. Now remember that this is a negative times a positive, so the overall answer will be negative. So you can just simply add the powers when you are working with the same base. All right? If you want to expand it like this, then you would notice that we would have m times m times m. In this case, the m occurs 3 times, so the power is going to be 3. You keep the negative sign because you will have negative m times m, give you a negative m squared times m again, give you a negative 3, negative m to the cube power. All right. Any questions so far? All right, here we have a little bit more complex in terms of powers. Now we have 2 unknowns. We have m and we have n. For the first term, we have 5m squared n squared. Second term, we have 3m n cubed. Now we are multiplying them. So what we want to do first is to multiply the numbers together. And we say 3, 5 give us 15. Now in terms of this, the symbols now, we just look at what we have. So we have a m squared here. We have a m here to the power 1. So we can simply add this power here, the 2 with the 1. We get 3. That means here we would have m raised to the 3rd power. Now if you look at the n's, this n is to the power 1. This n is to the power 3. When we add the powers of the n's, we get 1 plus 4, plus 3 give you 4. So this becomes n to the power 4. And that give you your final answer. Any question, guys?
Sir, pH, the,
Go
the,
ahead,
the, the,
Jane.
the M, sir, because
Yes.
it's 2 here, so you add the other M, that would be 1. So yeah, that's how you get the M to the third power.
All right. Your question is, did I add? All right, so ask the question again, Miss Green.
I'm saying, sir, you have 5M square
Right.
and N square. So for the answer, you have 15 to the 15M to the third power. So
All
I was asking if you add that M to this one, so that's how you got the third power.
right, so we're really not adding the M's. What we're adding is the powers.
Okay.
So this is M to the power 2, M to the power 1. If we add their powers, we get the result of the product of those two M's. Right? So M to the power square times M to the power 1. To get their product, you simply add their powers. So you will get M to the power 3. For the n's, you do the same thing. This is n to the power 1. This is n to the power 3. You add their powers. And so you get n to the power 4. That is just really kind of a short way of multiplying them, right? But suppose you were not so versed with adding their powers, you could simply expand them, count how many m's in all you have, count how many n's in all you have, and then erase back those to the total number of. All right, for instance, let me show you what I'm saying. So you could expand them like this, because you're saying that m squared means m times m. And then now you would have 5m times m times n, which would give you this n. You multiply now this part now, so you'd have 3m, so 3 times m, and this would be n cubed. You get 3 n's here. Following so far? Now, once you expand them like that, you go ahead and you multiply the numbers together. So you will get 15. Now, for the letter M, you count how many of them you have. 1, 2, 3. So because you have 3 M's, then your power going to be 3. So M will raise to the power 3. And then now for the N's, you count how many you have. 1, 2, 3, 4. So this is going to mean that N will raise to the power 4. And so this would be the longer way of doing it. The shorter way, you would just now look at the powers from up here and add them. So m to the power 2 plus m to the power 1. You add their powers, you get m to the power 3. Here, n to the power 1, n to the power 3. You add their powers, you get n to the power 4. And you would have multiplied it 5 times the 3. Is that clear to everyone? Let me see the hands of those who are following so far. All right, now let me now see the hands of those who are still not very clear on what is happening. All right, so I'll take it that you're all clear on what is happening here. All right, so that would be your answer. What about this one now? Can I ask Miss Green to give me the answer for this. Miss Green, what is the answer here?
Sir. Hold on, sir.
All right. Any volunteer who would like to try?
Sir, -6m and 3.
-6 m n to the power 3. Is she correct? Anybody agrees with her?
Yes, sir.
All right. And yes, she's correct. Now, what she did was follow the rule that I had mentioned before. You multiply the numbers, so you get 3 times 2 give you -2, in fact, so we get -6. Now for the m, how many m's you have? 1, and what power it raised to? To the power 1, so you just put back the m. For the n's now, you have an n here to the power 1, you have an n here to the power 2. So all you're going to do is just simply add the 1 plus the 2, so n would raise to the power 3. All right, so that's how she arrived at this answer. Any question? Everybody now comfortable? Miss Green, are you comfortable now?
Yes, sir.
Okay. All right, so you could expand it like this. You multiply the numbers, and then now you count how many m's you have. M to the only 1. You count how many n's. You have 3, and you would get the same answer. All right, so when dividing between numerator and denominator, we cancel where possible. All right, now canceling is not something unfamiliar to you, because you have been canceling once you have been learning fractions. You know how to cancel. It's the same principle that we are applying here. We're canceling something in the numerator with something in the denominator. All right. So what we do, we look for what we have in the numerator. Now we have P times Q over P. Now if you expand this, putting back the multiplication sign between them, what you notice here, you have a P common in the numerator with a P common in the denominator. So obviously you are able to cancel these. All right? After you cancel these, you only have remaining in the numerator, Q. So this would be the answer. So you want to look for what you can cancel first when you're doing simplify. All right, so that's the first example on how we cancel. The second one here, we expand by multiplying based on the powers. So 3p squared q, we would have 3. Now the power tell you how many p, the power here is 2. It tells you how many p's you have when you're multiplying out. So you'd have p times q, right? Do the same thing in the denominator, expand. So you have 1p, but you have q squared. That means you multiply q times q. Now, once you have expanded out like this, you cancel what is common in the numerator with what is common in the denominator. 3 can go into itself 1 time. 3 can go into 6 2 times. Now, a p in the numerator will cancel with a p in the denominator. A q in the denominator with a p in the numerator. can we cancel out anything else? Is there anything else left to be canceled in this?
No, sir.
Right, so what we do, we just write whatever remain in the numerator after we cancel. So we have 1 times P, give you back P in the numerator. And we write what remains in the denominator. So we have 2 times Q, give you 2Q in the denominator. And so after you cancel, then it would simplify to this. All right. Any question, guys? Let me just look at another one. Now, the same principle applies. You multiply out. And then now when you multiply out, you look for what is common in the numerator with what is common in the denominator. So 6 can go into itself. 1, 6 into 18, 3. X in the denominator cancel with an X in the numerator. We have a Y here, can cancel with one of the Y up here. We have a Z here, cancel with this Z here. Now, after we cancel, look for what remain in the numerator. We have 3, we have X, we have Y. So in the numerator, we have 3XY. In the denominator, only 1 remain. So it would be 3XY over 1, which is the same as just 3XY. Any questions, students? Let me see the answer, those who understand what is happening so far.
Sir, I'm not quite getting it.
Say that again, miss.
Sir, I'm not quite getting it.
All right. Do you understand what is being canceled?
Yes, sir. Q.
So in terms of the letters, the same letter that we have in the numerator, once you have another one in the denominator, you can cancel them out.
Okay.
All right?
Yes, sir.
First, we look for the common factor. What is common to 6 and 3?
Q.
No, man, 6 for the numbers. What you can use to cancel 3 and 6?
30.
Yeah, 3, because 3 can go into itself and 3 can go into 6. 3 into itself, 1, into 6, 2 times. All right, notice here, this P to the second power is the same as what? P times P.
Yes, sir.
P times P here. You see that, Michelle?
Yes, sir.
In the denominator, you would have only 1 P, but you have Q squared, which is Q times Q. So if you expand it like this by writing them in normal form without the power, they would expand and look like this. So after you do that now, cancel letters. So if you have a letter here, you look for the same letter up here and cancel. Cancel with that letter up here. Now, this 3 cancel with the 6 down here. After cancel and cannot cancel anymore, you look for what remained in the numerator, which is not canceled. So you have the 1, you have the P. Remember now, that means you have to multiply the 1 times P, you would get the P, right? Down here, what is not canceled down here? So you have the Q and you have this 2. So you have 2Q. You multiply them together. Follow?
Yes, sir.
All right, it's the same thing that we did with this one. Have x squared, that means you have to multiply x times x. We have y squared, you have to multiply y times y. Z. In the denominator, we have 6 times x times y times z. In canceling now, we see that for the numbers, 6 can go into itself 1, 6 can go into 18, 3. For the letters now, there's an x here that can cancel with an x here. Now we don't have any more x down here to cancel with this one here. So we leave that one. But this y can cancel with this y here. Now, no other y is remaining in the denominator to cancel out this. But that can cancel with this z. Now in the numerator, after we finish, we only have the 3x, this y. So we just group those together. We get 3xy. In the denominator, we only have 1. Everything else is canceled. So that would be 3x over 1, which is the same as just 3xy. Question? Everybody understand that so far? Let me see your hand.
Sir, I understand it now.
All right, good. All right, now I am now going to show you a shorter way of doing it. All right, now we're going to do it with the powers, right? So we're going to ignore what is happening here. And for this one, we're ignoring what is happening here. We're just working with this part. Ignore what is happening in the middle. If we are working with this, we see that obviously there's a p here that can cancel with this p, so you only have q remain. For this one down here, we can cancel 3 with 6. But the denominator has p to the what? Power 1, right? The numerator has p to the power 2. Now, if you have p to the power 1 down here, if you cancel out, if you take away 1 from 2 here, you only have 1 left. So when you cancel p to the power 1 with p to the power 2, you simply just subtract this power from that power. So if you take away 1 from 2, all of this cancel out and you have only p to the power 1 up here. Above you have q to the power 1, down below you have q to the power 2. So you take away 1 from 2 down here, you're left with 1. So all of this cancel out. Now when you look at what remains, so this p to the power 1 remain, which is the same as this. Down here you have this 2 and this q to the power 1, which is the same as just 2q. If you look at this one down here, you're doing the same thing. 6 into itself goes 1. 6 into 18 goes 3. The power x down here is 1. You cancel out 1 of this with 1 of this. You're left only x to the power 1. Cancel out, this is the power 1. Cancel out 1 of this with 1 of this. You have y to the power 1. Cancel z with z. So everything down here cancel out, but what will remain above is this 3, this x to the power 1, this y to the power 1. So you have 3xy. All right, so that's a kind of a little bit more tedious, but a shorter way of canceling. Any question? Let me see the hands of those who are comfortable about what we have just done.